No warning, no pause. A predator breaks from the darkness. The distance disappears in under 2 seconds. The prey does not have time to respond. Somewhere else, a flat water surface erupts, and what appeared motionless has locked onto its target before any sensory system could process the signal. Further out, a shape presses low against the ground and advances toward a feeding herd, each step silent, each yard closing, until there is no distance left to run. Across Africa, this moment is occurring continuously, in millions of different forms, by hundreds of different species. But the outcome is always decided by the same variable. Who calculated more precisely, and who was 1 second slower? This is Africa as it actually operates. No margin for error, no second opportunity, only the moment before and the moment after. The horizon ignites. The sun rises as a mass of molten heat, burning away the thin night mist. There is no wind. The air is motionless, dense, and dry. Temperature rises from 65 degrees Fahrenheit to 90 degrees Fahrenheit within 20 minutes. The ground fractures into sharp plates, hardened like concrete. Grass is yellowed and sparse. The environment is no longer habitat. It has become a thermal zone. Every organism enters an energy calculation, energy debt. Each unnecessary movement becomes a loss. If a cheetah fails a chase, it loses 30% of its energy reserve. If an elephant chooses the wrong direction in search of water, it risks the survival of the entire herd. Survival is no longer measured by strength. It is measured by conservation. An antelope stands motionless, reducing heart rate to retain water. Nyx emerges, a flexible muscular form weighing 110 pounds. She does not belong to a group. She operates alone. Under intensifying morning sunlight, her spotted coat does not serve display. It disrupts her outline within fragmented shadow. She moves directly across burned grassland. No sound, no excess movement. A male warthog separates from its group. 150 pounds of mass and aggression. The warthog digs into dry soil, actively searching for roots. It does not detect that each exhalation reduces distance to a predator. 20 feet, 10 feet. Nyx does not require brush cover. She exploits the prey's lack of awareness. She accelerates. A gray form crosses fractured ground at high speed. Nyx does not attack from the rear. She targets the critical point, the throat. Her jaws lock onto the trachea. A bite force of 500 psi collapses the airway within seconds. Nyx wins this encounter. She neutralizes the target as quickly as possible to preserve energy and eliminate injury risk. Her survival window extends by approximately 1 week. Nyx feeds immediately. She consumes rapidly. Exposed muscle tissue is torn apart. This creates a critical vulnerability. Nyx is operating outside her established territory. The scent of warm blood disperses through still air. It functions as a signal to other predators. Vocalizations cut through the open space. A pack of African wild dogs appears along the horizon. 15 individuals. They do not operate as solitary hunters. They function as a coordinated unit. The pack separates and forms a curved perimeter around Nyx. Numerical pressure increases by the second. 15 visual fixations remain locked on the lone leopard. Short, sharp barks establish encirclement communication. Below the tree, the wild dogs remain active. They are capable of sustained speeds of 40 miles per hour. Their anatomy prevents vertical pursuit. Nyx observes from above. She remains alive. She remains unfed. The warthog carcass is consumed within minutes. The hunt concludes without completion. Nyx preserves her life. The cost is an empty stomach and increasing energy deficit. The sun reaches its highest position. Ambient temperature exceeds 105 degrees Fahrenheit. Heat distortion rises from fractured ground. Movement across the landscape slows to near zero. Thermal stress now exceeds predation risk. A short sprint under these conditions can elevate core temperature to levels associated with neurological damage. Active hunting ceases. Nyx rests across a high tree branch. Her limbs hang downward to increase surface exposure to limited airflow. Heart rate decreases. Breathing becomes regulated to reduce moisture loss from the lungs. Below the tree, hyenas and large herbivores reach a temporary tolerant state. They remain close together within narrow shade zones. Proximity is accepted in exchange for reduced heat load. The ecosystem enters a short-term suspension state. This is not rest. It is survival through immobility. Any animal that fails to remain inactive during the 6-hour window will not persist to sunset. Silence acts as a surface condition. Beneath elevated skin temperature, metabolic energy is conserved. All systems prepare for renewed conflict as solar intensity declines. Late afternoon light casts long shadows across granite outcrops. This is not a random collection of individuals. This is a lineage-based system. Lionesses' sisters and mothers form the unbreakable core of the pride. presence is established through scent. They rub heads and necks together, blending individual odors into a single shared identity. This shared scent functions as an identification signal in low visibility conditions. Even these head contacts are not displays of affection. They are ritualized actions that reinforce physical cohesion before nocturnal hunting begins. While the pride rests, the male lion functions as a physical barrier. A thick mane protects critical blood vessels from disabling strikes. He is a combat-optimized body mass weighing approximately 420 pounds. His role is not hunting. His role is force application. He patrols territorial boundaries, marking vegetation with urine and producing low-frequency roars. These vocalizations can travel up to 5 miles. They induce physiological stress in any approaching rival. This is not display behavior. It is an acoustic warning. Cross this boundary, and the cost is lethal. The male does not rely on concealment. His presence alone signals absolute ownership. Pride organization operates with coordinated precision. Lionesses provide energy acquisition. They function as tactical units. A younger, faster lioness initiates the drive. She redirects antelope herds toward terrain constraints. Experienced adults remain stationary within dense cover. Their silence functions as a tool. movement follows spatial calculation rather than impulse. Encirclement angles are closed. Escape routes are removed. The male lion enters only when mass and force are required. If the target is a Cape buffalo weighing 1,500 pounds, lionesses can restrain but cannot terminate. This is when the male advances from cover. Speed is unnecessary. Mass is decisive. A full body impact of 400 pounds can fracture the spine of the largest prey. Within this structure, weakness is not tolerated. Each individual functions as a critical link. If lionesses fail to hunt, the pride experiences caloric deficit. If the male fails to defend territory against invading coalitions, the genetic line is eliminated. Incoming males will kill all existing cubs to reset reproductive dominance. One principle governs the system. Pride survival overrides individual survival. Survival pressure reaches maximum intensity. All animals within the territory enter a high-risk state. This empire is not sustained through trust. It is sustained through absolute control and efficient application of force. Under intense African sunlight, the river is not a place for rest. It functions as a fortified zone. Massive bodies weighing up to 3,500 pounds remain motionless, exposing only eyes, ears, and nostrils above the surface. Hippopotamuses do not swim. They walk along the riverbed, using body mass to control water space. Their sensitive skin secretes a reddish fluid that functions as a natural sunscreen and a strong antibacterial agent. Oh, this slow movement must not be interpreted as docility. The hippopotamus ranks among the most aggressively territorial animals on Earth. Any intruder, whether a 15-foot crocodile or human boat, entering this zone faces immediate lethal risk. When a male hippopotamus opens its mouth to an angle of 180 degrees, this is not yawning. It is a weapons display. Tusks measuring up to 1.6 feet in length are sharp and harder than ivory. A single bite can split a large crocodile. Bite force reaches approximately 1,800 psi. And how this raw physical pressure converts the river into a restricted zone. Crocodiles recognize the rule: maintain distance or sustain fatal cranial damage. On land, aquatic advantage is lost, but aggression increases. Running speed can reach 19 miles per hour. A 2-ton body in motion becomes an uncontrollable force. Any obstacle between the animal and the river is crushed. Hippopotamus life follows a cycle of isolation and force. By day, dominance secures access to water and shade. By night, grasslands are occupied through physical pressure. These animals do not exist for coexistence. They demonstrate a fundamental rule. Control of limited resources determines survival outcomes. Dominance does not require refinement. It requires decisive action and sufficient bite force to end conflict. A combined mass of muscle and bone weighing 12,000 pounds moves across the landscape. Elephant herds do not wander randomly. They follow routes encoded within the largest brain of any land animal. At the front moves the matriarch. She functions as a living data archive. In an environment where water access determines survival, her memory of a water source from 30 years earlier defines life or death for the entire herd. Elephants do not adapt to ecosystems. They force ecosystems to adjust to their presence. Using raw physical power, they push down large trees to access foliage. This action converts dense woodland into open grassland and creates habitat for grazing antelope. They also establish ecological corridors. Paths through dense thorn vegetation form after decades of repeated movement by massive feet. These routes become transit corridors for smaller animals. Luangwa. When other species withdraw due to drought, elephants initiate a different survival response. Using tusks and trunk, they excavate dry riverbeds. This is a precise extraction method. At a depth of 3 to 4 feet, groundwater begins to seep upward. Elephants create exposed water wells. This action produces an indirect support system for other species. After the herd departs, animals including leopards, antelope, and birds arrive to access remaining water. Elephants do not perform this behavior to support other species. They act under survival pressure for their own lineage. However, in environments where resources are exhausted, their presence becomes a critical link that prevents total ecological collapse. Under the intense heat of East Africa, a moving wall of dark muscle advances, lifting clouds of dust that obscure the horizon. This is the Cape buffalo. They do not wander. They move with coordinated discipline comparable to a unified formation. Each individual functions as a biological mass, weighing up to 2,000 pounds. Protected by thick hide and equipped with solid bone horns, forming a fused boss capable of deflecting extreme impact. Cape buffalo do not rely on panic-driven escape. When survival pressure increases, collective fear converts into coordinated force. The survival of this herd of 500 individuals depends on a single variable: water. Cape buffalo require a minimum of 10 gallons per day to sustain their large digestive system. During the dry season, when water holes disappear under temperatures reaching 110 degrees Fahrenheit, forced movement becomes unavoidable. The memory of lead individuals functions as a survival map. They retain locations of concealed water sources from many years prior. A navigation error or delayed movement results in collapse among calves due to exhaustion. Each step of the herd represents an energy calculation. Grass intake must offset a migration distance of 20 miles under direct heat exposure. As darkness falls, predation pressure increases. A lion pride follows the herd and targets vulnerable individuals. Calves and aging members face the highest risk. At this moment, the buffalo activate one of the most effective defensive structures in nature. They do not scatter. On a shared signal, the herd rotates outward and forms a closed circle. Adult males with fully developed horns position themselves at the perimeter. Calves and females remain protected at the center. This formation creates a physical barrier of horns and hooves. Within this structure, lions reach an impasse. To access prey, they must confront direct impact, capable of crushing the chest and horns, able to lift a 400-pound body into the air. Lions function as hunters. Cape buffalo determine engagement conditions. The most severe characteristic of Cape buffalo is not defense. It is counterattack behavior. This species displays persistent retaliatory response following loss of a calf. When a juvenile is killed, the herd shifts from defensive posture to coordinated force projection. Cape buffalo persist without reliance on speed or concealment. They persist through mass, numbers, and sustained resistance. Each day presents conflict against dehydration and predation. As long as the defensive circle remains intact and water knowledge transfers across generations, this muscle-based fortress continues to dominate the largest plains of Africa. Dust rises beneath the hooves of thousands of individuals. Zebras and wildebeest do not move together by chance. They form a survival alliance based on complementary sensory strengths. The primary pressure here is limited visibility. Within tall grass, a predator can approach to within 10 feet without detection. Zebras possess sharp daytime vision. Wildebeest rely on highly sensitive olfactory detection. A dual early warning system is established. Or if zebras detect distant movement, or if wildebeest register the scent of blood carried by the wind. the entire mass of tens of tons of muscle enters a full alert state. Silence is broken by a sharp warning snort. There is no time for verification. The first response is acceleration. Zebras can reach speeds of 40 miles per hour. Black and white stripes are no longer visual patterning. When hundreds run together, the stripes create optical disruption that interferes with predator targeting. Escape carries significant energy cost. A 2-mile sprint under direct heat can push body temperature toward heat shock. However, the cost of stopping is greater. In this movement, speed ranking matters more than maximum velocity. Older individuals, injured animals, and juveniles fall behind. After the disturbance, the herd halts approximately 1 mile away. Heart rate remains near 180 beats per minute. Eyes remain wide. The ears rotate backward to monitor sound. There is no complete rest in this system. The alliance reforms. Vigilance returns to maximum level. Ambient temperature reaches 112 degrees Fahrenheit. The water hole is no longer a resource. It becomes a biological trap. Thousands of animals converge into a confined space. Zebras, wildebeest, and warthogs compress along the edge. The water shifts from clear to opaque brown. Mud and waste accumulate. Compression increases. The odor of fear mixes with heated sediment. Each animal recognizes the risk. Thirst exceeds avoidance response. Beneath the still surface, a Nile crocodile weighing 1,000 pounds waits. It does not swim. It remains stationary. With breath-holding capacity exceeding 60 minutes, it becomes part of the mud substrate. Evolution has equipped it with pressure-sensing organs along the jawline. These receptors detect micro-vibrations when a prey animal enters the water. Distance is measured in millimeters. A zebra steps away from the group. It advances 2 additional feet to reach clearer water. One moment of inattention follows. The head lowers. Peripheral awareness is reduced. The surface erupts. There is no warning sound. There is only the fracture of leg bones as jaws close with a bite force of 3,700 psi. Impact force is comparable to a direct sledgehammer strike. The sequence concludes in under 5 seconds. The crocodile executes a death roll. Body mass is used to separate joints. Mud disperses. Dark red water spreads through the pool. High above the ground, dark points circle against a clear blue sky. White-backed vultures. They do not hunt. They track mortality patterns. With vision capable of detecting a carcass from 2,000 feet. They function as the first reconnaissance layer of the ecosystem. One individual lands and triggers a rapid cascade. Within less than 15 minutes, more than 50 vultures surround the carcass. Silence is replaced by sharp hissing sounds and heavy wing impacts. Time pressure becomes critical. At 110 degrees Fahrenheit, a carcass can decay rapidly and become a source of bacterial spread within hours. Vultures do not consume in a conventional sense. They remove biological waste. Using beaks with high structural strength, they penetrate thick hide left behind by other species. The vulture's stomach functions as an extreme chemical environment. Acidity levels approach a pH near 0. This concentration neutralizes lethal pathogens, including anthrax, plague organisms, and botulism-producing bacteria. They ingest material that would be fatal to other species and convert it into usable energy. Competition at the carcass is direct and uncompromising. Larger vultures displace smaller individuals. They crowd tightly and push against one another. Bare heads and necks, an evolutionary adaptation that limits contamination during feeding, become coated with blood and soil. In less than 30 minutes, a 150-pound antelope is reduced to a clean skeleton. No soft tissue remains. No decay residue persists. Vultures perform a critical ecological function on the savanna. By removing carcasses rapidly, they limit disease outbreaks. They reduce contamination of water sources and lower transmission risk for other animals. After they depart, the ground remains clear. Decomposition is complete. Nutrient cycling concludes and prepares the system for renewal. The environment does not accumulate waste. It operates through efficient and uncompromising recycling processes. Sunset colors the savanna before night dominates. Kilimanjaro fades into purple haze. One cycle of intense survival concludes. Pressure does not disappear. It transitions. As light fully declines, nocturnal dominance begins. Nyx descends from the tree. Eyes reflect moonlight. A new energy recovery sequence starts. A male lion's roar carries from territorial boundaries. Night order is re-established through sound. The savanna produces no heroes. It produces no villains. It provides no mercy. Only biological systems operate at full capacity against elimination. In a shallow mud pool of the Luangwa River, a Nile crocodile lies motionless. Its body is covered with dry mud to retain moisture. It waits, using almost no energy, until water and prey return. On a nearby grass plain, a dead antelope attracts several scavengers. Spotted hyenas arrive first. Their jaws crush the bones. Above them, vultures descend one by one. They move into the open spaces to feed on the remaining flesh. During the Luangwa dry season, carcasses become an important energy source for many species. Under the canopy of a mopane forest, a leopard moves slowly through dry leaves. As water sources decline, herds of grazing animals spread out and become more alert. Hunting, therefore, requires patience and precision. Farther across the grassland, herds of antelope move constantly in search of water. Many animals gather around the few remaining pools. Predators also wait at these same locations. In the Luangwa Valley during drought, the survival of every animal depends on a single factor: water. as the dry season continues. The Luangwa River becomes the only reliable water source in the valley. Animal tracks cover the banks. Elephants, African buffalo, antelope, and warthogs all arrive to drink. Lions, leopards, and hyenas follow them. Above the valley, vultures observe every movement. Within the narrow corridor along the river, the entire food chain gathers. During the day, the grasslands belong to grazing herds. At sunset, the balance begins to shift. Hyenas begin to patrol. Leopards leave their resting places. Lions move along the floodplain to approach antelope herds. Every movement within the Luangwa ecosystem is connected to water. This resource determines where animals gather, how predators operate, and when a hunt begins. An impala steps down to the bank of the Luangwa River in the late afternoon. Its head lowers to drink water. About 13 feet away, among sparse grass and broken leaf shadows, a body almost blends with the ground. The muscles tighten in an instant. The leopard lunges forward. The short distance leaves almost no time for pursuit. The jaws clamp onto the neck of the prey. 3 seconds later, all movement stops. In the Luangwa Valley, this big cat controls the night landscape in a distinct way. Its presence rarely announces itself with sound. Prey often detects the danger only when the distance has already become too small to react. Silence, precision, and concealment make the leopard one of the most effective predators in this ecosystem. The daily rhythm of the leopard takes place in concealment. Movement may continue for hours between scattered woodland patches. Every step placed on dry leaves is controlled. Instead of relying on long chases, the hunting method focuses on approaching close without detection. The attack distance is often only a few feet. In the Mopane woodland of Luangwa, many curved branches form natural platforms. The carcass is placed between two strong branches. The leopard returns several times over a few days to feed gradually. This method of handling prey reduces the chance of losing food and conserves energy for future hunts. Across generations, storing prey in trees has become a stable survival strategy. In the highly competitive environment of South Luangwa, success does not depend on maximum strength. Advantage belongs to the predator that reduces risk and uses each hunting opportunity in the darkness. A herd of nearly 100 African buffalo moves toward the Luangwa River. The dense mass of dark bodies advances slowly across dry grass. They form a defensive circle around the calves in the center. In tall grass ahead, 5 lionesses lie close to the ground. The distance between each individual remains wide enough to create a large encirclement. Their attention focuses on the same target. An older female buffalo falls behind the herd. The hunt has not yet begun, but the direction of the buffalo herd is already within the calculation of the ambush predators. As morning light spreads across the Mopane woodland, a deep roar emerges from the valley. The sound travels across the open canopy. Birds lift from branches. Antelope stop feeding and raise their heads. Within the Luangwa ecosystem, the roar of a lion does not serve only internal communication. It signals territorial control to the entire grassland. When the prey animal finally collapses, order quickly forms within the pride. Cubs approach first and feed on the softer tissue. Adult females follow next. Male lions usually feed last, even though they maintain territorial defense. A wildebeest, weighing nearly 440 pounds, separates from its herd on grassland near the Luangwa River. 5 spotted hyenas have formed a circle around the prey. The distance between individuals remains stable as the chase begins. The wildebeest accelerates, but the predators maintain pressure behind it. After 3 minutes, the strength of the prey declines noticeably. The group closes in from several directions. The hunt ends on the dry grass near the river. Along the mist-covered slopes of the Muchinga escarpment, spotted hyenas often appear during early morning or late afternoon light. For many decades, this species was associated mainly with scavenging. Field research in the Luangwa Valley shows a different pattern. Most of the energy used by hyenas comes from active hunting. Each individual belongs to a matriarchal clan. Within this social structure, females hold the highest rank. Adult females control access to food, positions within the clan, and breeding areas. Adult males usually occupy lower ranks within the social order of the clan. The massive body of the African elephant leaves few natural predators. However, this size also creates strong physiological pressure during long dry seasons. Water sources shrink. Vegetation declines week by week. The energy demands of the largest land animal therefore become a constant challenge. An adult elephant requires about 40 to 53 gallons of water each day. Food consumption ranges from about 330 to 660 pounds of leaves, grass, and bark. This large intake forces the herd to move almost continuously to maintain energy balance. In the Luangwa Valley during the dry season, locating resources occupies much of the day. The social structure of elephants centers on the oldest female in the herd. This individual leads the group using experience gained across many dry and rainy seasons. The herd moves along familiar routes remembered by the matriarch. In the Luangwa Valley, each elephant step continues to shape the landscape. Forest paths, open clearings, and temporary water pits all show the influence of the largest animal. On the continent, memory, social structure, and physical strength combine into a force capable of reshaping an entire ecosystem. Nile crocodile, nearly 13 feet long, lies still at the edge of a shallow lagoon. The water's surface ripples slightly as a massive body approaches. A male hippopotamus rises from the muddy water. The crocodile immediately shifts aside and maintains distance. body of an adult hippopotamus can reach nearly 13 feet in length and weigh several tons. This large mass, combined with long tusks, creates a strong threat at the water edge. A fully opened mouth can reach more than 3 feet wide. The bite force can cause severe injury to any animal that enters the territory. The skin of the hippopotamus contains almost no hair and is highly sensitive to sunlight. To adapt to tropical conditions, the body secretes a pale pink fluid across the skin surface. This substance is often described as blood sweat. In reality, it is a chemical mixture with several biological functions. Research published in 2023 by Kyoto University shows that this secretion functions as a natural sunscreen and also has antibacterial properties while maintaining skin moisture. The bacterial inhibition strength of this compound exceeds that of many common antibiotics. Although hippos spend most of their time in water, they do not swim in the same way as fish. Instead, the body pushes along the river bottom in the short bursts. An individual can hold its breath for about 5 minutes before rising to breathe. The heavy body often appears slow. When threatened, a hippopotamus can reach speeds close to 30 miles per hour on land. This speed is notable for an animal weighing several tons. The social structure of the species centers on a dominant male. A group usually includes several females together with calves. Each group occupies a specific section of river or lagoon. The male maintains control through loud vocal signals, threat displays, and violent fights when intruders appear. Beneath the murky water of the Lufupa and Kapamba lagoons, Nile crocodiles are often nearly impossible to detect. Only the eyes and the tip of the snout rise slightly above the surface. This motionless position can continue for hours. The attack moment occurs precisely when prey enters the dangerous range. An adult individual can reach a length close to 20 feet and a mass exceeding 1,500 pounds. This size places the Nile crocodile among the largest reptiles in Africa. Its body form has changed very little over millions of years of evolution. The jaw structure, armored scales, and powerful tail demonstrate a biological design highly specialized for aquatic hunting. Sound rises from rock outcrops covered with mopane woodland as sunrise reaches the Luangwa Valley. Short calls echo between the stone walls. This signal belongs to Chakma baboons, one of the largest primates with complex social structure in southern Africa. As light increases, individuals leave their sleeping positions on high rocks and move down the hillside. In the Luangwa Valley, this primate species often occupies rocky high ground, forest edges, and buffer zones near the river. This terrain provides two important advantages. Food resources appear around forest margins and grasslands close to water. High rock outcrops provide wide visibility for detecting danger at long distance. An adult male can weigh nearly 88 pounds and reach a body length of more than 4 feet. This size is nearly 3 times larger than females within the same troop. Gray-brown fur allows the body to blend with the red soil, exposed rock, and short grass of Luangwa. On a dry grass plain near Mopane woodland, 9 African wild dogs sit in a circle. No individual moves quickly. Short sounds come from several animals. The sounds resemble a sequence of sneezes. After a few seconds, the entire pack stands almost at the same moment. A decision has been made. "15 minutes later, the group begins a pursuit. An impala becomes the target. The hunt ends faster than expected. The success rate of this species often reaches about 80%. African wild dogs represent the only surviving members of the genus Lycaon. Their body structure differs clearly from that of other canids. Each foot has 4 toes instead of 5, as in most dog species. The coat displays irregular patches of black, yellow, and white. No 2 individuals carry the same pattern. One easily recognized feature is the large, rounded ears. This structure allows detection of sound over long distances. The ears also help release heat when the pack moves under high temperatures in the valley. An adult individual usually weighs between about 40 and 79 pounds. Body length ranges from about 3.3 to 5 feet. This size is smaller than that of the spotted hyena. However, the hunting efficiency of wild dogs remains higher in many habitat conditions. Data from 2024 reported by the organization Painted Dog Conservation shows that the hunting success rate can reach about 80%. This level exceeds that of many other large predators within the same ecosystem. The key factor lies in pack coordination. On the western slopes of the Muchinga Range, environmental conditions differ clearly from the Luangwa Plains. Temperatures are usually lower. Surface water nearly disappears during many months of the dry season. Rocky terrain and sparse vegetation create a challenging environment for small animals. Vervet monkeys weigh between about 7.7 and 17.6 pounds. Despite their modest size, this primate shows strong adaptive ability. The species occurs in many habitats across Africa. These include rainforests, grasslands, mountain slopes, and coastal areas. The diet of vervet monkeys is highly varied. Leaves, fruit, flowers, and insects make up most of the food intake. Bird eggs, small animals, and sometimes lizards are also consumed. One notable behavior is geophagy. This behavior involves eating soil. The soil contains minerals that supplement nutrition and assist digestion of certain plant compounds. Research published in 2023 shows that vervet monkeys can learn through observation. In experiments using food boxes, when one individual discovered how to open the container, others watched and quickly repeated the behavior. Knowledge therefore spreads through the troop across generations. The sun slowly sets across the Luangwa Valley. Shadows of Mopane woodland extend across the dry floodplain. During a single day, many survival strategies have appeared across this landscape. Leopards approach prey through silence. Lions hunt through the strength of the pride. Spotted hyenas rely on hunting efficiency and carcass processing. Elsewhere in the valley, African elephants guide their herds toward water sources remembered from earlier dry seasons. Despite their differences, all strategies converge at the Luangwa River. When water withdraws from smaller channels, animals from many habitats gather along the riverbanks. Prey species, predators, and scavenging birds share the same narrow space. Today, this ecosystem faces pressure from climate change and human activity. The future of South Luangwa depends on whether these ecological connections remain protected long enough to continue functioning. The sun burns across the wide grasslands of Africa. Hot wind moves through dry yellow grass, and the entire savanna vibrates under intense light. From a distance, the land appears quiet. But within the low grass, hundreds of animals are constantly watching, moving, and responding to one another. Herds of wildebeest move slowly across the grassland. Their heads remain raised as they check the open space around them. Nearby, zebras stand close together. Their ears rotate constantly to detect every small sound. Farther away, several Thompson's gazelles graze, but their legs remain ready to run within a fraction of a second. Along the edge of the grassland, predators have already appeared. Lionesses lie low within the grass and wait with patience. On a distant mound, a cheetah observes a group of antelope. Its body remains tense like a compressed spring before release. At the same time, a spotted hyena moves slowly across the savanna. Its large ears constantly search for signals of opportunity. On this land, no species holds absolute power. Each predator and each prey animal survives through a different strategy. That constant competition keeps the savanna active. At midday, the sun stands high above the savanna. Light strikes the dry yellow grass, and the air vibrates from heat. Under the limited shade of an old acacia tree, a lion pride rests. At the center of the pride lies an adult male lion. A thick, dark mane surrounds the neck and shoulders and makes the body appear larger than the others. The animal lies still with the head slightly raised. The eyes move slowly across the grassland ahead. However, that appearance represents only the surface of power within a lion pride. Closer observation reveals that the real function of the pride does not depend on the male resting under the tree. It depends on the lionesses that quietly control the daily rhythm of the group. Lionesses form the operational system of the pride. They perform most hunting activity. They protect and raise the cubs. They maintain the flow of energy that allows the pride to survive day after day on the savanna. Lions usually hunt most effectively at dusk or during night hours, when low light allows closer approach to prey. However, the savanna does not always provide ideal conditions. When hunger continues for too long, A lioness leaves the shade even during the intense heat of midday. Far away, a herd of zebras grazes across the grassland. Black and white stripes move slowly within the yellow grass. At that distance, the herd does not detect the predator. The lioness stops and observes. The eyes remain fixed on a single zebra standing slightly apart from the herd. The distance begins to decrease. Hot air causes the horizon to shimmer. Sunlight distorts the view. The grassland remains almost motionless. The stillness continues until the entire scene appears frozen. Then within a single moment, the silence breaks. The lioness bursts from the grass. The zebra herd runs in panic. Dust rises under dozens of hooves. Rapid breathing mixes with short roars as the predator closes the distance. The chase lasts only a few seconds. A leap from behind. Claws grip the body of the prey. Teeth lock onto the throat. Within the hot dust of the savannah, the hunt ends as quickly as it began. But the power of lions does not exist only within that moment of violence. The real dominance of this predator comes from social structure. Each member of the pride performs a clear role. Lionesses hunt and raise the next generation. Male lions defend territory and maintain stability within the group. If lions dominate the savannah through the strength of the pride, the cheetah survives in a completely different way. It does not rely on numbers. It does not rely on the ability to compete directly with larger predators. The entire survival strategy of this species depends on a single weapon: speed. Across the open grasslands of the savannah, a cheetah usually appears alone. There is no hunting formation. There is no roar announcing territory. There is only a slender body standing still within hot wind and bright light. Unlike lions that are often most active at night, cheetahs hunt mainly during the day. Strong daylight helps them avoid direct competition with more dangerous predators such as lions or hyenas. From a low mound, the cheetah stands still and observes. Far ahead, a group of impala moves slowly across low grass. Most individuals maintain safe distance from each other, but there is always one animal that steps slightly outside the formation. The cheetah lowers its head. The body presses close to the grass. Each step moves forward slowly and carefully. Distance is calculated meter by meter. During this stage, patience is as important as speed. The chase unfolds at speeds very few land animals can sustain. But even with this advantage, a small mistake can end the hunt. A delayed turn, a misstep, a moment of lost rhythm. A single error can reopen the distance and allow prey to escape. If the final distance disappears, the cheetah swings a front leg toward the hind legs of the prey. The impact causes the antelope to lose balance and fall into the grass. In the next moment, the cheetah closes in and grips the throat of the prey. Even after killing prey, the cheetah is not completely safe. A lion may appear at any moment. A hyena may detect the scent of blood from a long distance. Even jackals may approach if the opportunity appears. For this reason, the cheetah must feed quickly after the kill. On the savanna, speed allows it to obtain food. But the exhaustion after the chase also means the meal can be stolen at any moment. For many generations, hyenas have been associated with an image that lacks respect. A slightly hunched back, an unusual walking pattern, and their sharp, laughing calls have led many observers to believe they are only scavengers on the savanna. But when night spreads across the African grassland, this assumption quickly proves incorrect. Beneath the dust and darkness of the savanna, the spotted hyena is one of the most effective predators in the ecosystem. They do not rely only on carcasses. In many situations, they are the animals that actively bring down prey. These sounds can travel across many miles of open grassland. They signal that a hyena clan is active in the area. If social organization forms the foundation of their strength, the body of the hyena serves another purpose: complete utilization of available food resources. The jaws of the spotted hyena form one of the most powerful biting systems among carnivores. Jaw pressure is strong enough to crush large bones that many predators cannot break. When prey is killed, hyenas do not consume only the soft tissue. They break bones to reach the marrow inside. Bone marrow provides a highly concentrated energy source. Before entering the Darien Gap, We have just left the vast grasslands of Africa, where power appears in open light and wide space. There, predators often stand exposed against the yellow grass. The roar of lions travels across the savanna. High-speed chases unfold beneath an uncovered sky. But on the other side of the ocean, the rules change completely. The Darien Gap lies between Panama and Colombia. It is a massive stretch of primary forest that connects North America and South America. This region functions as a biological bridge, where many animal species have moved between continents for millions of years. No highway cuts across this forest. Most of the landscape still preserves nearly its original natural structure. The air in Darien is dense and humid. Layers of forest canopy stack above one another, breaking sunlight into faint, scattered beams. Underfoot lies soft ground, covered with thick layers of leaf litter and roots. Visibility rarely extends beyond a few dozen yards. Every movement is partly hidden by tree trunks, vines, and shadow. Here, space does not expand horizontally like the savanna. It expands vertically. In such an environment, speed is no longer the greatest advantage. Instead, the ability to remain concealed, move silently, and use the vertical structure of the forest becomes the key to survival. Within this green maze, a small movement sometimes passes across a wet tree trunk. There is no clear sound, only a soft shadow sliding across moss and bark. This is the margay. The margay is a small cat species within the genus Leopardus that lives in the tropical forests of the Americas. Unlike larger predators such as the jaguar, the margay rarely appears clearly on the ground. Most of its life unfolds high above, among dense branches. This cat represents a refined product of evolutionary history that followed the formation of the land corridor between North and South America. While many large mammals dominate the forest floor, the margay follows a different path. It occupies the vertical space of the forest. In addition to agility, the margay also possesses a rare hunting tactic among wild cats. In several documented cases, the margay can imitate the call of tamarin monkeys. The sound can attract curious individuals or young monkeys closer. When the distance becomes short enough, the hunt ends quickly. In the Darien forest, hunting intelligence sometimes does not depend on muscle strength. It depends on a brief acoustic signal. The margay therefore represents a very different type of predator. Its power does not lie in body size. It lies in balance, camouflage, signal deception, and hunting within the canopy. While predators move among the tree trunks, another world exists beneath the forest floor of Darien. At the base of massive trees, long lines of leaf-cutter ants move continuously like a working column. Each ant carries a green leaf fragment several times larger than its own body. From a distance, the moving line resembles a narrow green road. At first glance, it appears that the ants carry leaves as food. But the reality is more complex. Leaf-cutter ants do not eat the leaf fragments they carry to the nest. The leaves are only raw material. Underground, the leaves are cut into small pieces, crushed and mixed with secretions from the bodies of the ants. This mixture becomes a biological growing medium for a single species of fungus. This fungus is the true food source of the entire colony. The system resembles a small agricultural process. Leaf-cutter ants cultivate fungus. They maintain the fungal gardens, remove infected sections, and regulate conditions that allow the fungus to grow. To protect this garden, specialized bacteria live on the bodies of the ants. These bacteria produce antibiotic compounds that prevent harmful mold species from developing. Higher above the ground, the canopy layer of the Darien forest forms another world. Among large branches, a group of spider monkeys moves through the treetops. They do not leap in a hurried manner. Each movement occurs with precise control. Long arms reach forward to grasp the next branch. The body swings across open gaps. The long tail wraps around a branch behind the body. This tail functions like a third hand. With this structure, spider monkeys can hang, balance, and travel across wide gaps in the canopy. But their role extends beyond agile climbing. While feeding on fruit, spider monkeys carry seeds across different parts of the forest. These seeds later fall to the ground or pass through the digestive system and are deposited far from the parent tree. Through this process, they help the forest expand and regenerate. If spider monkeys represent movement within the forest, another primate species represents its sound. In the Darien forest, the most dangerous predator rarely appears before its traces are seen. On the wet mud of the forest floor, large round footprints press deep into the ground. The edge of leaf litter has been pushed slightly aside. A low branch moves briefly and then becomes still again. There is no roar. There is no obvious movement. But these signs show that a large predator has just passed through. It is the jaguar. The jaguar is the largest cat in the Western Hemisphere, and a descendant of ancient predator lineages that once moved through land corridors connecting the Americas. For thousands of years, this species has become the dominant predator symbol of tropical forests, from Mexico to the Amazon. The body of the jaguar is not long and slender like that of the cheetah. It is thick, heavy, and solid. An adult can measure close to 6 feet in length and weigh more than 200 pounds. The shoulders are broad, The legs are powerful. Dense muscles lie beneath the spotted coat. Each step carries substantial weight. The jaguar does not need to be the fastest animal in the forest. But the jaguar is not only a predator of the forest, it is also a predator of water. In Darien, the boundary between land and water is rarely clear. Small rivers, swamps, and flooded zones intersect with forest trails. The jaguar is one of the few large cats willing to enter these environments. It swims with strong ability, and sometimes its prey lies beneath the water surface. It bites directly through the skull. The bite force of the jaguar is extremely powerful for its body size. Thick jaws and strong canine teeth allow it to pierce skull bone or the armored shells of several animals. The bite of the jaguar usually produces an immediate result. Once the jaws close, the chance of survival for the prey becomes extremely small. Within the wet layer of leaf litter on the forest floor, a small movement is almost impossible to detect. A thick brown body slowly coils within the shadows. It is a boa constrictor. Unlike many other predators, the boa does not rely on speed. It also does not possess venom. Its strategy is much simpler. It waits. A boa can remain motionless for hours, sometimes longer, blending with the color of soil and leaf litter. When prey moves close by accident, the hunt unfolds within a very brief moment. The initial strike almost never misses. Immediately after the bite, thick, muscular coils wrap tightly around the prey's body. Each time the prey exhales, the coils tighten slightly more. Death does not occur from a large wound. It occurs through circulatory restriction when blood can no longer move normally through the body. When the prey becomes completely motionless, the boa begins swallowing it head first. The digestion process may then last for many days, sometimes several weeks. In exchange, the snake can survive for a long period without hunting again. The boa represents a very different survival strategy. Hunt rarely, but each successful hunt provides energy for a long time. Within the dark and humid leaf litter of the Darien forest, bright colors sometimes appear. Blue, yellow, or intense red. These animals are poison dart frogs. Their colors do not function as camouflage. Instead, they act as a warning signal, a clear message directed toward predators that this body should not be eaten. These frogs contain powerful toxins within their skin. However, they do not produce the toxins themselves. They accumulate alkaloid compounds from their diet. Their primary food includes ants, termites, mites, and small forest insects. These toxins gradually accumulate inside the body and become a strong chemical defense. When kept in captivity with a different diet, many poison dart frog species lose most of their toxicity. This fact demonstrates that their defensive strength is borrowed from the surrounding ecosystem. In the Darien forest, even the most dangerous biological weapons can depend completely on environmental integrity. Before they are seen, they are often heard. A sharp call cuts through the humid forest air. The sound travels from the high canopy down into the valley. Then large wings appear within the sunlight, passing through the leaves. Macaws. Their feathers display bright red, blue, and yellow colors that stand out against the dark green background of the rainforest. But these colors do not exist only for display. Within dense canopy environments, color helps individuals recognize each other from long distances and maintain social bonds. Macaws usually live in pairs or small groups. They nest inside large tree cavities located high above the ground where most predators cannot reach. When dawn arrives, the atmosphere shifts again. Thin mist dissolves across the water surface. From this pale layer, a slender shape appears. The great egret steps forward like a white line drawn across the wetland. It does not create the impression of aggression. It creates the impression of precision. Long legs carry the body through shallow water with almost no disturbance. The eyes remain fixed on the surface. The neck contracts like a spring held in tension. At the correct moment, the bill extends forward like a spear. There is no chase. There is no descent from the sky. The great egret succeeds by remaining motionless until the opportunity appears. When seasonal water levels rise, this bird often nests on low trees or floating vegetation where land predators have difficulty reaching. During several short weeks of the breeding season, young birds learn a quiet but essential lesson. Observe, wait, act only when the opportunity is within reach. When water levels drop, flocks disperse along newly formed channels. With every step across the mud, they return minerals to the wetland through waste, contributing to the nutrient cycle of the aquatic system. When darkness falls, nothing actually ends. Across Africa, millions of individual animals continue operating under the same rules: hunt or be hunted, consume or be consumed. No species stands outside that cycle. No size, no speed, no strategy eliminates that pressure entirely. Each species has found its own answer. And the sum of all those answers, every hunt, every escape, every death, produces a system that has been running on its own for millions of years without any coordination from the outside. Death is not an ending. It is a transition point. Energy returned to the soil, to the grass, to the next generation already waiting to begin its own cycle. Africa does not stop. It only continues, indifferent, unrelenting, and without exception.